You're welcome to today's lecture. We take a look at chemistry today. Chemistry. We'll take a look at chemistry. Today is 16th January 2024. So we'll look at chemistry. The topic is chemical combination. Chemical combination. Okay, as usual, I'll list the topics, the subtopics under this topic. And after that, I'll talk about the behavioral objectives. So what we tend to achieve at the end of the topic. So under this topic, we look at stoichiometry as per your JAMB syllabus. Stoichiometry. We look at what? Stoichiometry. We look at stoichiometry. Then we also look at the laws of definite and multiple proportion. We look at laws of definite and multiple proportion. Then we also look at law of conservation of matter. Can you see the board from there? Good. Law of conservation of matter. Then we also look at Gay-Lussac's law of combining volume. Gay-Lussac's law of combining volume. Gay-Lussac's law of combining volume. We also look at Avogadro's law. Avogadro's law. Then we look at chemical symbols and formula. Chemical symbols and formula. We look at chemical symbols. Chemical symbols. And what? Formula. We look at chemical symbols and formula. Then we also look at relative atomic mass based on carbon-12. We look at relative atomic mass. Relative atomic mass based on what? C12. We look at relative atomic mass based on carbon-12. Then we look at the mole concepts. Mole concepts. And what Avogadro's number is all about. Mole concept and Avogadro's number. Mole concepts. These are what we expect to cover. The subtopics we expect to cover under this chemical combination. If we are able to cover this thing and you know this thing very well, there's nothing, at least when it comes to chemical reaction, you're able to, there's nothing you will not be able to do there. Now, what do we tend to achieve at the end of this topic? What we tend to achieve is that at the end, you are expected, or you should, at the end of this topic, you should be able to, you should be able to perform simple calculation. You should be able to perform simple calculation. I'm dictating, you can put it down. The student or the candidate should be able to do what? Perform simple calculation involving formulae, equations, chemical composition and mole concepts. You should be able to, number one, perform simple calculations involving formulae, equations, chemical composition, and the mole concept. Mole concept. You should be able to do that by the end of this topic. So if after the topic you are able to do this, you need to go back to the topic again and study it. That's the meaning. You should also be able, number two, to deduce the chemical laws. Deduce the chemical laws from given expression / statement / data. You should be able to do what? Number two, deduce the chemical laws from given expressions / statement / data. Remember, can you remember the last thing we did? One of the last thing we did in our chemistry class last year, when a statement that a particular element A combined with B, blah blah blah, and you're asked to say the law that guides that combination. Can you remember? When we were talking about law of multiple, can you remember? Can you remember? Good. So this is what we mean by being able to deduce the chemical laws from a given what? Expressions / statements / data. Then you should also be able to do what? Number three, interpret graphical representations related to these laws. The laws mentioned here. You should be able to do what? Interpret graphical representation related to these laws. Sometimes you may see a graphical representation of a particular concept or law. You should be able to say, okay, this graph represents this particular law or this particular concept. Then number four is that you should be able to do what? Deduce the stoichiometry of chemical reactions. You should be able to deduce the stoichiometry of chemical reactions. So these are the subtopics, as well as what you expect to be able to do at the end of these topics. Now let's move straight to stoichiometry. Let's start from here. Even though starting from the scratch, but you are not new with this, but this stoichiometry is somehow. So that's why I want to start from here, okay? Good, because most of the things I'm mentioning here has a lot to do with moles, related to atomic mass, mainly. Good, let's start from this, stoichiometry. Have you heard of the term stoichiometry before? Any idea of what stoichiometry talks about? Who can help us? Any idea of what stoichiometry talks about? No idea. Now listen, you know, in a chemical reaction that reactants come together, right, to form what? Products. Now let's assume you have, can I clean this board? Can I? Okay. Since I left this thing in the class. Since I left it, help me with that, with this. Now, please. Right, thank you. Is it wet? Thank you. Okay, this one is better. Okay, so when you have reactant A combining with reactant what? B, to either produce C alone or C plus D, as the case may be, depending. Let me put C plus D. These are the reactants, and these are the what? Products. Now, this combines with this. There's a relationship between amount of this that combine with the amount of this to produce these products. There's a relationship that's between these reactants with respect to their amounts to compare with the what? The products. If you touch any of the amount of this, it will affect the amount it will react with here. Am I completing? And also it also affects the products. Now, the study of this relationship that exists between the amount of the reactants and that of the products is what stoichiometry is what all about. So stoichiometry deals with the relationship that exists between the amount of the products of the reactant itself, themselves, and that of the what? Products. So when you trying to find out the amount can be mass, it can be moles, it can also be volume, it can be weight, mass, it can be moles, it can also be what? Volume, when it comes to mainly gaseous reactant or products. But the point there is that this amount can be weight, mass, volume, or what? Or moles. So this is when you now look at trying to find out how the amount of this. That's why sometimes if you have a balanced equation, that's when you understand it better. If you have a balanced equation now, you find out that no matter the amount of this reactant you bring together to react with this, there's a fixed amount that can react with a fixed amount of this. Any remaining one will be excess. That excess will not react. Is that fixed amount that will react with it? That will react with it to give the what? The product. Any other one will be what? Excess. That one sometimes you get gases. Like now, if you have two gases, like now, hydrogen and oxygen, to form water, for example now, like hydrogen and oxygen now, and oxygen to form what? Water, which is steam, right? Is it balanced? Is this balanced? So what should be here? What should be here? Here come. So the ratio with which they combine is what? 2 is to what? 1. And they produce what here? 2. Are we together? Yes. Have you now seen? No matter the amount of oxygen you pump here, no matter the amount of oxygen you pump here, it can only react with half of the hydrogen. The amount of oxygen that will react with hydrogen will be half of what is here. Let's assume you spark with 20 cm3 of what? Oxygen. Sorry, hydrogen. If you like, use 100 cm3 of what? Oxygen. Here. The amount that will react with this hydrogen will be what? What? Half of this, which is what? 10 cm3. That's the amount of that will react with this 20 cm3. If you like, pack 1 million cm3 of oxygen here. So excess here is what? 90 cm3. Have you now seen how the amount of this, the ratio of the ratio of this to compare with this affects the amount that it will react with? Am I communicating? To give you a particular what? Product. So when you consider all these things, we are going into what? Stoichiometry. You are going into what? Stoichiometry. Now, there are some things I want to talk about here. Remember I told you, even though we'll still talk about mole in detail, but let me just, here we'll talk about, you hear something like reacting mass, molar mass, right? You are no longer, you are not alien to this. Mole concept. What is a mole of a substance? Using carbon 12 as a standard, you hear things like a mole of a substance is the amount, a mole is an amount of substance. A mole of substance is the amount of that substance that contains the same elementary particles as contained in 0.012 kilogram of what? Carbon 12. 0.012 kilogram of what? Carbon 12, C2. So when you say that a mole of a substance, let's assume you want to talk about 1 mole of a substance. 1 mole of a substance is simply the amount of that substance that have the same elemental what? Elemental particles as contained in 0.012 kilogram of carbon what? 12. Carbon 12 atoms. Now, from here now, look up. From here now, this numerical coefficient represent the moles, okay? But when it comes to gas, this can be moles, it can also be what? Volume. Have I converted? Can be moles, it can also be volume or even molecules, okay? But basically, we leave it at what? Moles. So here you see something like this, N, maybe here it should be X or something. This N moles of what? A. X moles of what? B, okay? Now, we know that, let's look about molar mass. What is molar mass? Molar mass from the tree it came from here, molar mass. Molar mass of a substance is mass of 1 mole of that substance. Now, look at this thing now. Look at, let's use, sorry. Can I clean here? All right. Look at this now, you have molar mass. Mass of what? Of what? 1 mole of a what? Substance. So molar mass of a substance is mass of 1 mole. You're sleepy. Molar mass is mass of 1 mole of a substance. Now let's look at in a reaction now. Maybe let's look at a reaction between, let's say, sodium chloride plus, sorry, what am I saying? Sodium hydroxide. Let's look at this neutralization reaction. Even though it's 1-1, you will not see the effect much anyway. But let's just see. Plus HCl. You have what? Sodium chloride and what? And what? Water, right? Let's not talk much about their states. Now look at this thing now. The effect may not be much here, but let's just look at. If you watch now, how many is this equation balanced? Is it balanced? Sodium is here. Sodium is here. OH is balanced, right? Good. Now, this is 1 mole, hope you know. So sodium combined with sodium hydroxide combined with HCl, a mole ratio of what? 1 is to what? 1. Am I computing? Now, if you look at this now, this sodium hydroxide is 1 mole, okay? 1 mole, right? It's 1 mole of what? Sodium hydroxide. Now, mass of 1 mole of sodium hydroxide is mass of this, which is written as what? The molecular mass. True of us? True of us. You simply do what? Calculate the what? relative atomic mass of each of the component what? Elements. And hope you know that inside this sodium hydroxide now, hope you know this sodium, why is sleeping? Stand up.
Actually, it's not fine.
What happened?
We went for hospital this morning.
Yeah, sorry. No. Now, so we have here now, in this sodium hydroxide now, even inside this sodium hydroxide, this sodium hydroxide contains 1 mole of sodium atom. 1 mole of sodium and 1 mole of what? Hydroxide of what? Ion. All together. Inside this sodium. Call it, okay, if it breaks down, you have 1 mole of sodium, 1 mole of this. But if you go that deep to the atoms, you see you have 1 mole of what? Oxygen. Okay? 1 mole of what? Hydrogen. But as a compound, this compound is 1 mole. And the mass of this 1 mole, is now calculate add up the respective relative atomic mass of this what? Component element. It will give you the molecular mass, which is the mass of 1 mole, which is certain as what? The molar mass. Okay? So now that's why you can say that the molar mass of sodium hydroxide is what? This is 23, right?
Yes.
Plus what? 16 plus what? Plus what? 1, which is what?
14.
Is it 14? 14. But since we're not talking about molar mass of 1 mole, so it should be in gram per what? DNQ. No. Gram per what? Mole. Am I completing? The unit is gram per mole. Molar mass. Mass of 1 mole. Molar mass is in gram per what? Mole. Gram over mole. So based on this now, if you know the molar mass of substance and you know the number of moles, you can actually calculate the reacting mass of that substance in a particular what? Reaction. Okay? That's how we came up with the concept. The reacting mass, which is N, which is R, reacting mass, which is R, is equal to what? Sorry, that number of moles. The number of moles is equal to what? Reacting mass over what? Molar mass. This is a powerful relationship. The number of moles is what? The reacting mass over what? Molar mass. So if you know the number of moles, you can actually use it of that substance to find the mass that is participating in the reaction, which is called the what? The reacting mass. So number of moles is equal to what? The reacting mass over what? Molar mass. Any confusion? Any confusion? Are you with us? Is it clear? Is it clear? Good. Now, I'm trying to explain a lot of things before we go into what? Calculation, because this topic is all about calculation. But I want to explain 1 or 2 concepts before we move into what? Calculation. I've talked about the moles, the molar mass, reacting mass. Now, another thing I want to talk about, this is for solid, liquid, but sometimes you have in volume, in gaseous reactant, or in a reaction that involves what? Involves what? Gas. Remember I told you something, that this amount we talk about in stoichiometry can be mass, can be what? Volume, can be what? Mole, right? We have discussed moles, talk about mass. Now let's go to volume. Now for gas at STP, 1 mole of any gas, 1 mole of a gas, 1 mole of any gas at standard temperature and pressure occupies a volume of what? 22.4 dm³. Please note this relationship too. We call it the molar volume. Molar what? Volume. The molar what? Volume. So at STP, 1 mole of a gas is equal to what? Occupies what? 22.4 what? dm³. Know this relationship. Sometimes you may see equation that has both the solid, just like the one you have when you have what is it called? When calcium triazocarbonate 4. Break down here, you see calcium oxide and carbon 4 oxide being evolved. Am I communicating? Or when you react add magnesium to HCl, you see hydrogen giving off, liberated. Yeah, so if you know this relationship, you can actually calculate the volume of the gas that is what? Liberated. Am I completing? So this is where this thing will help a lot. So we call it molar volume. You can simply say that the molar volume of a gas, because molar volume is volume of what? The volume occupied by 1 mole of the gas is molar volume. So molar volume of gas at STP is what? 22.4 dm3. That's the molar volume of a gas at STP, which is certain as saying the volume occupied by 1 mole of it. So molar volume of a gas is the volume occupied by 1 mole of the gas at what? STP. And it's what? 22.4 dm3. Okay. So with this now, I think I've mentioned the important point I need to mention. So now let's our reference book for today is New School Chemistry for Senior Secondary School by Oseiyo Ababio, as revised by L.E.S. Apanisi and Herbert Igwe, 2016 edition. So most of the things we are going to discuss today will be from this textbook. So I will pick some examples here from this textbook. We'll solve it on the board to buttress the point I have been making here. Okay, so put down this question, or do I copy it on the board? Which is better? Should I dictate or copy? Which is better for you? I should copy it on the board. Okay, let me copy it on the board. Okay? Okay, let's look at this question. Excuse me. Okay, let's look at this question. Let me copy from the textbook. Okay. The question says, calculate the number of moles of calcium chloride that can be obtained from 25 grams of limestone in the presence of excess hydrogen chloride. Here are the relative atomic masses of the component elements of these compounds. Shall we continue? Yes. Okay, now let's look at this question again. It says, calculate the number of moles of calcium chloride that can be obtained from 25 grams of limestone in the presence of excess hydrogen chloride. The first step to accurately deal with questions that has to do with stoichiometry is to write down the balanced chemical equation of the reaction, okay? If you have any error in the chemical reaction, in the equation, you will never get the answer. So you must first of all get a balanced chemical equation of the reaction. Here we have limestone. Limestone is calcium triose carbonate 4, as you can see there. Reacting with excess hydrogen chloride to produce what? Calcium what? Chloride and what? What else do you think can be produced? Is it only calcium chloride? Look at the equation. Well, okay, let me write down the equation. Plus what? HCl. What do you think will be produced?
Both calcium chloride and
calcium what? And what again? Water. And what again?
CO2.
And what?
CO2.
CO2. Thank you. And what? CO2. Because this thing will break down. Hope you know. Releasing what? CO2. Releasing what? CO2. Then look at this equation. Is it balanced? Who can balance this equation for us? Look at it very well. And also tell me about the state. What states are they in? What state? What states? Calcium carbonate is in what state? By state I mean solid, liquid, gas, aqueous. Which one?
Solid.
Solid. Okay. This one, uncle.
Gas.
Yeah?
Gas.
Gas. Hydrogen chloride. Don't mind this. It should be what? Aqueous, okay? Okay? What next? This one, uncle. Calcium chloride should be what? It's aqueous now.
Okay.
Water should be what?
Aqueous.
Liquid. This one, uncle.
Gas.
CO2 is what? So this is what? Solid. This is what?
Aqueous.
This is what? Aqueous. This is what?
Liquid.
Liquid. This is what?
Gas.
That. Now look at this. Is this equation balanced? So yeah, let's balance the equation.
HCl.
So calcium is okay. What and what? So what do we do?
2 in HCl.
2 is 2 where?
In HCl.
HCl. What else?
Then
Calcium is here. Calcium is here. Let's take it step by step. Carbon is here. Carbon is here. I agree. Oxygen is how many here? 3, right? Oxygen.
3.
1, 3. Hydrogen is 2 here, right? It's 1 here. And the CCl is what here? Chlorine is 1 here, 2 here. So if you put here now to balance, you now have 2 hydrogen, 2. Then chlorine is what? 2 is balanced now. Now this is the first step to be able to. If you make any error here, forget that question. You can never get that answer. Forget it. Now let's having established the balanced chemical equation. Let's look at the question again. It says we are calculating the number of moles of this calcium chloride. Please, if there's anything you don't understand, please ask questions. Don't keep quiet, okay? Please. Here now, what we want to establish here is that we want to calculate the number of moles of what? Calcium chloride. That we do what? Obtain from this reaction. But we are told that 25 grams of limestone, 25 grams of this, reacted with this to form this. But we want to calculate the amount of this. So, first of all, what is the mole ratio? How many moles is there? 1 mole. Here you go. 2 moles. Here, 1 mole, 1 mole, 1 mole. Now, so actually, from this equation of the reaction, 1 mole of what? Calcium triocarbonate 4, which is limestone, yields what? Yields what? 1 mole of what? Calcium what? Chloride. 3 of us, from the equation of reaction, 3 of us, good. 1 mole of this yields 1 mole of calcium chloride. The question says we should calculate the number of moles, but we are giving mass of limestone to avoid. Remember, you are writing jam, so try as much as possible to take a step that you will not, run beat about the bush before you get the answer. Here, 1 mole of calcium carbonate 4 yields 1 mole of what? Calcium chloride, right? Now, but we are told what is the mole of calcium chloride that will yield by 25 what? Gram. They have moved the amount now to gram in mass instead of what? Mole. The best way to solve this question is to just move this to what? Mass, and bring down this mass and set a proportion and know what this mass can produce here. You get the answer straight. If you want, you move this one to mass, move this one to mass, and start bringing it back again to the answer. Even if you use only HCl to calculate this, you still get the same answer. Am I completing? So now, what we want to do here now is this. Remember what I said about molar mass? Molar mass is mass of 1 mole, right? Mass of 1 mole. We are told 1 mole of calcium carbonate. Calcium triocarbonate 4. Are you feeling cold now? You're feeling hot? Jay. This is serious. Me, I'll catch cold. Sorry, I'll catch cold. Now, 1 mole of calcium triocarbonate 4. What is mass of 1 mole of calcium triocarbonate 4? Is the molar mass, true or false? So simply calculate the molar mass of this and get the answer. So what is the molar mass of this from this 40, right? 40, right? 40
plus 12 plus 48.
Plus what?
12 plus 48.
Which is what?
It's like 100. Yeah.
Which is what?
100.
100 gram. Okay? 100 gram per what? Mole. True or false?
True.
Good. So this is 100 gram. So this 1 mole has a mass of what? 100 gram. So if 100 gram of this yields 1 mole of what? Calcium what? Chloride. Are we together? Are we together? Now, what will 25 gram? What mole of calcium chloride with 25 gram of this yield? What mole will it yield? What's the answer?
I think we are going to look for that mole of CaCl2.
What's the answer first? Do this one I ask you. I know where you're going to. Just this one first. Let's see how it goes. What's the answer? You are writing Jambo. Be careful. You can convert this. You are beating about the bush. Remember, you have limited time. I'm not complicated. I know where you're going to, but it's not necessary. If you move it, you still come back.
How can we now times 26, 25 times 1?
Dude, if 100 gram of calcium carbonate yields 1 mole of calcium chloride, 25 gram of calcium carbonate will yield X now. It's not true. Find the X, do it now. Have you done it? 4.
0.25.
Do it, limit what you did.
I'm not doing it.
I am saying 4.
It's 24.
Do it now. Cross multiply. I find X. If 100 gram is 1 mole, 25 gram will now be X. True of us. Find X. What's the answer? 0.25 moles. So X is not. Okay, look up. So if you cross multiply, that means X is now equal to what? Is what? 25 gram times what? 1 mole. Over what? 100 gram. True of us. Gram will cancel gram. We are left with mole. 25 divided by 100 is what? 0.25 what? Mole. So 25 gram will actually yield 0.25 mole. If I allow you, you guys start moving this in 1 to gram. I'm wasting your time in the exam hall. That's why I say forget about it, because you are, how do you are told to find the mass of calcium chloride that will yield. The hell, that's when you move this to what? You calculate the molar mass of what? Calcium chloride. So now, let me ask a question. If you now ask to calculate the mass of calcium chloride, what are you going to do? Here should not contain the molar mass of calcium chloride. True or false? Which is 40 plus that 5.5 times 2 is what? 70 what?
70.
It is not 70. That 5.5 times 2 is what? 71. So 71. Please also watch your. Don't be always punching calculator. It do not help you in JAMB. You people are writing JAMB. You are writing JAMB. You are punching this phone. Don't just, please, allow your brain for some time to do all this, do these things. You are punching it. Me, I've already told you the answer. 35.5 is what? 71. So let's assume you are asked to calculate the mass of calcium chloride that will be produced. So what you simply do is move this to what? Molar mass, which is what? 71 grams. So that means 100 grams will yield what? 71 grams. 25 grams will now yield what? So what it means that anywhere you see 1 mole of calcium chloride, you put what? 71 what? Grams. So it now becomes 25 grams times what? 71 grams over what? 100. Over 100 what? Gram. So simply multiply this and divide by 100 and get your answer. You don't need calculator. Multiply it now. Yeah, do it. Keep that phone. I do it. No. Tell me the answer. I give you 30 seconds. Oh yeah, do this now and tell me the answer. Fast. I'm talking to you. All of you. Oh yeah, do it and tell me the answer, please. Don't always punch calculator up and down. Just simply multiply 25 by 71 and divide it by 100. Do decimal movement into piam and get your answer. So we have 71 times 25. 65. 35. 2. 14. 5. 35. 2. 14. This is 5. 7. 1. This is 10 will cancel it to move here from here to here. Another 0 will go to move the decimal point to this place. So you have 17.75 gram. 17.75 what? Gram. So have you now seen it now? because you have asked to find the what mass. That's why you start. So that's why I told you don't forget about that you what you are telling me here.
If I get, how can I now get that 0.25?
If you
Now that I've gotten this 17.75, how can I get that 0.25? Like changing it back to more.
okay, if you want to move this, I won't give you a formula here now. I should ask you that question. I give you a formula. Open the formula I gave you. What would I give you? What would I give you? That number I should ask. This one asking I should not ask. Oh yeah, answer it now. Oh yeah, what the formula I gave you that joint molar mass, reactive mass and number of moles. What's the formula?
N is equal to
Reactive mass.
reactive
Oh yeah, you use it to move it to. You use it to move it back to moles, number of moles. It will give you 0.25 mole. Do it. Let me see.
Which one is my reactive mass? Which one is
This is the reactive mass now. Is that not the mass? This is the reactive mass. Why do it? Let's see.
my moles? Now, which one?
It's not what you're looking for.
So my number is what?
Number.
My N is what?
Wait, dude. I don't like the question you're asking me. I should ask you this question. You're asking me.
Reactive mass over the potence.
Success. I thought you listen now. So I should be asking you that question now. Not you asking me. Oh, yeah, answer. Which one should be the molar mass for calcium chloride?
For carbon. Molar mass is 71.
Oh, yeah, do it now. So which one should be the reactive mass?
17.75.
Then find the number of moles.
Okay.
Was it okay? She's back. She went out before. She's now back. Oh, yeah, do it. What's the answer?
I need to press catheter.
Okay, you need to press calculator. Okay. So, is this thing clear? Any confusion here? No confusion, right? Good.
So,
Okay.
you call me for the weapon.
It's your choice. It's your choice.
The boss me.
Anyway, we have barely 30 minutes to end this lecture. But you can do it. It's okay. It's 5:21. We'll soon end the lecture, sir. So if it's what you can wait until the end if you can. But if you cannot, you can do no problem. So it depends on what you want to do.
That page is continue.
Okay. It will seem 6 o'clock. So let's just conclude. You know, we didn't start on time. Now you want to go again. Alright, so now let's solve another question that has something. Let me look for another question that has something different. Something in additionally, so we can. Okay, I think this number 2 question on this table, in this table will make sense. Let's solve this second question. Okay. The second question says, let me write on the board as usual. Can you see the board from there? Okay. If when you're done, let me know so we can start. Are you done? You are done, right? Okay, let's start. The question says, what mass of lead 2 trioxonitrate 5, that's the formula, would be required to yield 9 grams of lead 2 chloride. That's the formula. On the addition of excess sodium chloride solution. So these are the relative atomic masses of the components, elements of these compounds. Solution. Remember I said the first step is to do what? Write down the balanced chemical equation between lead 2 trioxonitrate 5 and the sodium chloride, because it's lead 2 trioxonitrate 5 and sodium chloride that will react to form a precipitate. So lead chloride and the sodium trioxonitrate 5, these are the products that will form. So let's write the balanced equation. So we have lead 2 trioxonitrate 5. Lead 2 trioxonitrate 5. This is aqueous solution, is an aqueous, plus sodium chloride solution is also what? aqueous to produce lead
Chloride.
2 chloride, which is what? Solid, plus sodium triisonitrate what? 5, which is what? Aqueous. So this is the equation. So now let's look at this equation. Is it confusing? Is it confusing? It's not. Now let's look at this equation. Is it balanced?
No.
Balance it. Oh yeah, let's balance the equation. I should add 2 where? Okay, let's have one lead. Lead is here, right? Lead is here. So let's put a blind eye on lead. Nitrogen is how many here? 2, right? Nitrogen is 1 here. So there's a question mark, okay? For nitrogen. Oxygen is how many here? 2 times 3 is 6. And oxygen is how many here? 3. There's also a question mark for what? Oxygen. Now sodium is 1 here and sodium is 1 here. It's balanced. But we can do something here for sodium. Chlorine is 1 here. Is 2 here. So if we put 2 here, it will render everything here 2, right?
Yes.
In an attempt to balance chlorine, we have rendered everything here 2. So 2 is sodium here, so 2 can now come here, right? And if we put here in front of sodium here, it has rendered everything here to 2, right? That means nitrogen, that is 2, has been balanced here, true of us. And oxygen, that is 2 times 3 is 6, has also been what? Balanced here, true of us. So the equation is what? Balanced. So now that we have balanced the equation, let us bring out the mole ratios. Number of mole of lead 2 5 here is what? 1 mole, right? So 1 mole of lead 2 5 combined with what? In ratio of 2 what? 2 moles of what? Of what? Sodium chloride what? Solution. To yield what? 1 mole of what? Lead 2 chloride and 1 mole of what?
2
And 2 moles of what? Sodium triisonitrate 5. Sorry. Let me just put 2 moles of sodium triisonitrate 5. So we have 1 is to 2 as 1 is to what? 2. So the mole ratio is now 1, 2 up here. Then 1 and what? 2. Now having brought out the mole ratios, let's look at the equation again. We are asked to calculate the amount, the mass now, they are specific, the mass of lead 295 that will be required to yield 9 grams. So 1 mole, I can clean here now, so I've gotten what I'm looking for, so I can clean here. Okay? Let me clean everything here and write it well. So that means 1 mole, remember, 1 mole of this, you talk about the what? The mass of 1 mole of lead 2 what? Nitrate, 3 of us is what? Molar mass of lead 2, right? So simply calculate, add up the relative atomic masses of these elements as stated in the formula. So 1 mole of this has what mass? I add up 207, right?
Plus 20.
This is 207, right?
Plus 28.
Plus what?
28.
Everything here is okay. You done it already.
Yes, 20.
No, let's do it together. Here is 14, right? Plus
48.
this is what? 48. Everything 2, right? 48 plus 14 is what?
62.
Is what? This is 10, 58, 62. Times 2 is what?
124.
124 plus 204. 207 is what? 33 what? 331 gram, right? Right? So 1 mole. Look up. 1 mole of lead 225 has a mass of what? 331 gram. That's the meaning. Okay? Good. Remember, our concern is between lead 2 nitrate and what? This one will yield. So mass of 1 mole of lead 2 nitrate will yield lead 295 will yield mass of 1 mole of what? Lead 2 what? Chloride. So let's calculate that of lead 2 chloride. 1 mole of lead 2 chloride is what? What's the mass? Let's calculate it. Lead is still what? 207, right? 207, right? Plus chlorine. Chlorine is what? 35.5.
71 plus
Is what? 71. So we have 35.5 times 2, which is what? 71. So here is what? 207 plus what? 71, which is what? 278 what? Gram. Is it clear? So mass of 1 mole of lead 2 chloride is what? 278 gram. So going back, what it means is that 331 gram of lead 225 yields what? 278 gram of what? Let me write it out well. What this implies is that 331 gram of lead 225 yields what? 278 gram of what? Lead 2 what? Chloride. 331 gram of lead 225 yields 278. We got, you know how we got this 278, right? So what this means that 331 gram of lead 225 yields what? 278 gram of what? Lead 2 chloride. But we are asked to calculate the mass of lead 225 that will yield 9 gram of this. So that means X of lead 2 325 will now yield what? 9 what? Gram of what? Lead 2 chloride. So this X is what I'm looking for. So let's cross multiply and get our X. So X is now equal to what? 331 gram times what? 9 gram over what? 278 gram. What's the answer? This gives us around 10 point something. What's the answer? You can punch your calculator if you cannot. So what's the answer? Feel free to punch. Punch us. Oh yeah, punch. You don't want to punch again? Okay, so what's the answer? 10 point what? 10 point what? Ten point what? So 10.7 is okay. So the answer is what? 10.7 what? Gram. So 10.7 gram of lead 225 will yield 9 gram of lead 2 chloride. Is it clear? So that's the answer. 10.7 gram. If you are done, let's see if you can solve one more question before we go into. We have basically discussed everything you need to know here. All you just need to solve questions and be going. We have already discussed everything you need to know. So you just solve questions and be going. Alright, so we can solve another question. Okay, the next question will involve gases. So I like it. The next question will involve gases so that we appreciate what we're talking about. The next question will involve gases. Even though it's talks about weight anyway, but no problem. To involve gas. There is the next one after this one will also now start talking about volume calculation. Are you done? Alright, so let's look at the next question. Let me clean so I can clean now. Alright, thank you. So please, on your own, solve as many questions as possible under this topic. Please solve as many questions as you can on your own. Question that has to do with stoichiometry, please. Solve as many as you can. So let's look at the next question, the third question from this textbook. Let me write it down as usual. Okay. Please, if you're done, let me know so we can start. We can solve this question. Are you done?
Yes.
And you kept quiet. I said you should let me know. Alright, so now let's look at the question. The question says, determine the mass of carbon 4 oxide produced on burning 104 gram of ethane. This is the formula for ethane. And these are the relative atomic masses of the component elements of the compounds. Now, solution. As usual, balanced chemical equation. This is just combustion of hydrocarbons. Whenever hydrocarbons undergo combustion, what we produce is simply what? We have C. This is the formula for ethane, right? Plus what? Oxygen. We give what? Plus what? Plus what?
Yes.
Water, right? Carbon 4 oxide and what? Water. Is it balanced? Is this balanced? Let's check if it's balanced. Tell me if it's balanced. If it's not, let's balance it. What is their state? Is there any liquid there? Is there any liquid here? It's combustion and heat. Everything here is gas. Okay? This is steam. This is a gases. So this is gas. Gas. What? Gas and what? Gas. This is not ordinary water now. It's steam. Okay? It's not liquid water. So everything. So let's check if this equation is balanced. Is it balanced? Okay. So now let's balance it. Let's check whether it's balanced in the first place. Carbon is 2 here. So it's not balanced, okay? So now let's attempt to balance it. Let's go. Carbon is 2 here, right? Is 2 here. Is 1 here. Let's put one big question mark for carbon. Hydrogen is 2 here. Is 2 here. Let's just smile a bit. Oxygen is 2 here. Is how many here? 3. Is also not balanced. So here we have carbon is 2 and 1 here. Oxygen is 2 here and 3 here. So what do we now do? What do we now do? What do we now do? Hydrogen, don't have issue. Anything you add there, it will take it. But let's look at this oxygen. Let's look at this oxygen. Oxygen is 2 here and 1 is here, right? So if you put 2 here, right? It becomes what? 4. Wonderful. Then what happens to hydrogen? Hydrogen will do what? We have issues. So you need to balance this hydrogen, okay? So if you put 2, in an attempt to balance hydrogen, you now have the hydrogen is now 4, right? And we say we put 2 here, right? So let's see how far we can go with this. If you put 2 here, hydrogen is now 4. Hydrogen is 4, correct? Carbon is 2 here. Carbon is still having issues here, right? So what do you now do? If you now put artificial 2, just put 2 with one leg. Put it. Let's see what will happen. Okay? So 2 is here. Carbon is 2 here. Oxygen here will now become what? 4, right? But here 4 plus what? 2, 6. If you add 3 here,
To be balanced.
are you sure it's balanced? Let's see now. Let's see whether it's true. Oh yeah, carbon is what? 4. Ta-da! Then look up now. Carbon is 4. Is it balanced? Carbon is 2 here. Is it balanced? So let's that's why I say we put an artificial 2. So let's make here what? 4 with all confidence, okay? So if here is 4 now, carbon becomes 4, hydrogen becomes what? 4, correct. Oxygen 8 plus 2, 10. So here should be what? 5. So 5 comes here. Is it balanced now? It's balanced. Any confusion? Chim, are you with us? Eh? See, we are playing around this to ensure that everything is balanced. That's what we are doing. Everything is balanced is now. Carbon is 4 here. Carbon is 4. Hydrogen is 4 here. Hydrogen is 4. Oxygen is 10. 8 plus 2. 10 is balanced. This is now a balanced equation. We can now start our what? Calculation. We can now do what? Start our what? Calculation. So that let's now start our calculation. The question says, let's go back to the question. Determine the mass of carbon dioxide produced on burning 104 grams of ethyne. Look up, please look up. You know all this while we've been using 1 mole, just multiply and go away. But there are 2 moles here. So let's look at their mole ratios. This is ethyne is 2 moles, right? Oxygen is what? 5 moles, right? To produce carbon dioxide, which is what? 4 moles, and water, which is what? 2 moles. So ratio of 2 is to what? 5, as 4 is to what? 2. This marker is not writing well again. I think we'll end this class after this because this board is becoming something else. And I don't really think our audience, don't you think they can see, the audience can see what we are writing on the board, because the board is now, let's just see how far we can go. Now, so we have 2 is to 5 as 4 is to what? 2. Now, if you now check this, you understood this one now, right? So I can now clean as usual and start the calculation now. I can now clean and start the what? Calculation. Now, look up. Remember, our concern is ethyne and what?
CO2.
Because of on the question, ethyne and what? CO2. So 2 moles of ethyne. What is the mass of 2 moles of ethyne? It's simply 2 times the molar mass. True of us? Because mass of 1 molar mass is mass of 1 mole. So 1 mole, mass of 1 mole is simply calculate the relative molecular mass. That gives you the mass of 1 mole. But mass of 2 moles is 2 times molar mass of what? 2 times molar mass of what? Ethyne. So 2 moles of ethyne is written as 2 times what? Molar mass of what? Of what? Ethyne. True of us? So what is the molar mass of ethyne?
26.
You've done the calculation, right? Because carbon is 12 times 2, 14. 12 times 2, 24. Plus hydrogen, 2, 26. So that means 2 moles, look up. The mass of 2 moles of ethyne is simply what?
52.
2 times what?
26.
26 grams. Please, if you're not following, let me know, please. 52 grams. So 2 moles of ethyne weighs what? 52 grams. Okay? Let's do the same thing for what?
CO2.
CO2 is how many moles now? 4. So 1 mole of CO2 weighs what? So 4 moles of CO2 weighs what? 4 moles of CO2. 4 moles of CO2 is equal to what? 4 times what? Molar what? Mass of what? CO2. What's the molar mass of CO2? 44, right? So that means 4 moles of CO2 is certain as saying 4 times what? 44 grams, which is what? 8. No, it can't be 8.
What is what? Oh, sorry.
What's the answer first?
176.
170 what?
6.
170.
176. What times 4? 6.
Because 8 times 2.
176.
176, good. 1 what? 7 what? 6 grams. So, remember, we sustain, listen, see what we sustain. We move 2 moles of ethyne to mass and move 4 moles of what? Carbon dioxide to what? Mass. So for ethyne is 52 grams. For carbon dioxide is what? 176 grams. So we can now start our calculation. So from the equation, so the question says determine the mass of carbon dioxide produced by burning 104 gram of what? Ethyne. So for ethyne, 52 gram produces what?
2 moles.
2 moles again.
CO2.
We have left moles now.
CO2.
What the mass of CO2 to produce?
176.
Good. So 52 gram of ethyne will produce what? 176 what? Gram of what? CO2. Now, 104 gram of ethyne will now produce what? 104 gram of ethyne will now produce what? We call it what? X. Are we together? So let's cross multiply. X now becomes what? 104 gram times what? 176 gram. All over what? 52 what? Gram. So what's the answer? 104 times 76 divided by 52 is what? It's simple now. See, it's simple now. Just divide this. 104 to 52 times 2 is what? 104, right? So if 104 divided 52, it will give you what? 2. So use 2 gram, we cancel gram. Use 2 to multiply 176. What's the answer?
352.
352 what? Gram. So 104 gram of ethyne will produce what? 352 gram of what? Carbon dioxide. That's the answer. 352 gram of what? Carbon dioxide. Any question on this? Any confusion on that? I'm waiting for question. In the absence of any question, we'll end today's class here to continue on Thursday. You see the table, right? Mm-hmm. So I'm waiting for questions. All right, for the audience, please, if you have any question, feel free to ask. You can call the number on the screen, on the board, 081 3868 200 We have a few minutes to entertain questions. If you have any question, please call this line now, and I will attend to your questions. We have a few minutes to the end of this class, so feel free. Please, on daily basis here on TikTok, we hold our lectures 4 p.m. to 6 p.m. on daily basis. Sometimes in the morning during working hours, we also hold in our purely science courses, purely pharmacy courses in the morning during working hours in the class. Like today we had live lecture on dispensing, and many of you were there up to 5 hours and something. Thank you very much for being with us. So here today is chemistry. This evening is chemistry. So feel free if you have any question. We are discussing the topic stoichiometry of reactions. So if you have any question, feel free to call. We have a few minutes to end this lecture. We have 3 minutes to go. So look at this well and see if there's any question or any confusion. Okay, every Saturday, 7 a.m. to 7:10 a.m., I organize academic competition I titled Academic Battle with Farmer Tanti the Schoolboy. Every Saturday, features a particular subject. And the registration for this academic battle is completely free of charge. So the flyer for the academic competition is on my TikTok page. So feel free to get the information. Then the link, for the link for the registration, chat me up on WhatsApp and I'll give you the link. Registration is free of charge and the battle competition is online. There are prizes to be won. Share this with your friends, your colleagues, your students. Someone out there may be in need of this. Please invite others to join us every day, 4 p.m. to 6 p.m. every day on TikTok for academic exercises. And God will bless you as you do so. Please follow me on TikTok. After watching, please follow me on TikTok. Go to my profile, click on the Instagram there, subscribe to my YouTube channel, and also follow me on Instagram. Even on Facebook, I'm there also on Facebook as From Eternity the Schoolboy. If you have any question anytime, feel free to drop your question. Alright, thank you very much, and God bless you. Alright, we end here. See you next time.